Now that we've had some basics and gotten those out of the way with perpendicular bisectors and angle bisectors, I want to take a minute just to show you how to do a little bit more of an elevated construction, such as a 45-45-90 triangle or a right isosceles, which is what its formal definition is, or formal name is. So we're going to start with a segment, and we don't want this segment to be super long, so I'm just going to click here to here, just a very short segment, just to illustrate this point. And what we want to do first, think about 45 and 45. We're looking for two 45-degree angles, which are somewhat difficult to get with constructions. But what we do know how to do is to create something perpendicular. And in fact, if you just go to your menu, constructions, and then look at number 1, now we do have the option for a bisector, but it's not necessary here. We actually want a perpendicular line. And then you click the segment. Okay, that will create the perpendicular, and then click where you want it to go. So what I'm going to do is put a perpendicular line at this endpoint, and I'm going to put a second perpendicular line at the second endpoint. And that's where I'm going to start for our 45-45-90 degree triangle. And what this does, you'll notice here, you now have two 90-degree angles above this line, right here and here. And your students, when you go to teach them this, hopefully what they will recognize is, or at least maybe you can lead them in this way, is to think about how 90-degree angles are really just two 45 degrees. So what have we done already that allows us to take one 90-degree angle and cut it in half? And hopefully they know the answer to that. That's to go and find the angle bisector of each angle. So we click on one of the sides, we click the vertex. Oops. Not sure what just happened there. Let's try this again. Menu. Sometimes it just takes a little bit there. So I'm going to click on the side, click the vertex, click the other point. So there's my first one. Click on the side, click the vertex, click the other side. And you can see already what's occurring here is we have a triangle in the middle. Now what you can do, it's kind of a neat thing here, you can do an intersection point on those two lines, the angle bisector lines. And so now there's a third point right up here that connects, and we have our triangle. Okay. Now, what's really neat is once you have this going on, you can actually click one of the original vertices and you can start to play around and manipulate this triangle. And you'll notice that no matter what I'm doing, that triangle in the middle is staying isosceles. Both of the legs are the same length. And the top angle is 90 degrees. Now, we can verify this a couple of different ways. If you go to your menu button and choose measurement, the first thing you can do is measure the length of these sides. If you click on one of the points, go to the other point, that will tell you how long, and you can just drag it over, how long your left side is. Click on the bottom right, click on that top point, and my right side is also the same length. So the isosceles part is 100% accurate. No matter what I do, notice from this on, this is really great visual for your students. I can manipulate it, rotate it, whatever happens, the left side and the right side are always balanced. You can also measure the angles the same way. Go to menu, measurement, let's verify that our angles are indeed 45, 45, and 90. So I'm going to measure that top angle. Yep, that's 90 degrees. I'm going to measure my left angle. Definitely 45. Measure my right angle, which will also be 45. So there we go. I can move that inside if I want to, just to make it, just to make it a little bit neater and for your students to easily see that no matter what, we can make this triangle as big as we want. We can make this triangle as small as we want. We can even turn it on its edge. We still have two 45-degree angles, one 90-degree angle, which creates a right isosceles triangle. Don't forget to save, file, save, and we're done.